if everybody would take a minute and turn to page 7 in your notes packet, okay, and you're going to be taking notes in your notes packet. Okay, so everything I write down, you write down. So you had an Edpuzzle video last night, and it talked about solving basic log equations, which you see right up here at the top of page 7. And basically you learned this little rule, circle the base, run the race. So what that does is it just takes an equation that's in log form, in other words, we've got a log here, and it makes it into something that's more manageable, something that we're more used to. Okay? All right. So we start by circling the base, run the race. So I'm looking at number 21. Please make sure that you're writing this down. So you're going to circle that base, which is that subscript, and you're going to run the race. Remember, we always cross the finish line over to the other side there, and that's our circle the base, run the race. So what we do is you are just going to write x. Now the run the race, remember, that becomes your exponent. And then what's left over, which is the 64, gets written on the other side. Our goal is to get the x to be isolated by itself. So in other words, we want to get rid of this 2/3, but it's an exponent. What we're going to do is we're going to multiply by the reciprocal, but it has to stay an exponent because 2/3 is an exponent. And what I do to one side, I'm going to do to the other. By doing that, what happens is this will disappear because I've got 6 over 6, which is 1. So that's just x to the first. And as we know, x to the first, we can just write as x. And then from here, I've got 64 to the 3/2 power. Now remember, power over root. Power over root. We're going to take that 64, and we are going to square root that, and the reason why we're square rooting is this is the root. So if the root is 2, that means we have a square root. Remember, we always have a 2 written here. If nothing else is here, we assume that to be a 2. And after that, we are going to take that and we are going to cube that. Oops, let me put that right there. Okay, I don't need those parentheses, sorry. So then I take the square root of 64, which I know is 8, and then I'm going to cube that value. Final answer, x equals 5/12. Okay, so make sure you're taking notes in your notes packet. Now, for number 23, I would like you to try it by yourself. Pause the video, try it. You can ask the person next to you, hey, what did you get? Let me see what you got. Oh, how'd you get that? Or help the person next to you, and then turn the video back on. All right, so you are going to circle the base, run the race. I've got 81 to the 1/2 power equals x. Now remember, again, just like the last one, we have power over root here. X is already by itself, so it's kind of like what we had right here, okay? Whereas up here, we had the 2/3, we had to get rid of the 2/3, and so on and so forth, but x is already by itself, so we just have to figure out what this is. So I'm going to do power over root. I have the square root of 81, technically raised to the first power, but we know that anything raised to the first power is just itself. I'm really just looking for the square root of 81, which is 9. Okay, make sure that if you made a mistake that you fix it in your notes packet. Make sure this is all written in your notes packet. Okay, so then now let's look at number 25. And again, we're going to do the same thing. We're going to circle that base, run the race, and that's going to be x to the -3rd power, and that equals 8. All right, so the x is not by itself. We've got a -3rd power there. So if we want to get rid of a power, all we have to do is take the reciprocal of it. So that's -3, it becomes -1/3. We're going to do the same thing over here, -1/3. That's going to cancel this out, okay, and that's just going to give us a plain old regular x. And we have 8 to the -1/3 power. Now let's just talk a little bit about that negative. Remember, when you have a negative exponent, we can make the exponent positive if we put it in the denominator. So let me just rewrite it like that so you can see it. Okay? So getting rid of a negative exponent, we just take this and we flip it. So it becomes 1 over 8 to the 1/3 power. And I'm going to do power over root. Okay, so that's going to give me x equals 1 over. All right, so the root is 3, 8. And then we are technically to the first power. You don't have to put it, or you can. That's up to you. But we know, obviously, anything to the first power is itself. So basically, I'm just looking for the cube root of 8, which I know is 2. And there's your answer. Okay, so again, make sure that you're taking notes in your notes packet. All right, if you would turn the page, I'm on page 8 now, and 26 was in your Edpuzzle video from last night, so we're going to look at 27. And we're going to do the same thing again. So we're going to circle the base, run the race. Okay, so that's going to give me x plus 3, that quantity squared, right, equals x cubed plus x minus 2 over x. Okay, so you can do a couple of things first. You can either distribute this out first and then multiply by x, or you can multiply by x and then distribute that out first. It's up to you. Really doesn't matter. Let's just make sure that you are aware that that's going to be over 1, so we're going to cross multiply. So remember that this really means x plus 3 times x plus 3. And that's what I'm going to be distributing out, okay? So that's going to give me x squared. Now, just to show you, I'm going to have plus 3x and plus another 3x. So that's going to be plus 6x plus 9. I'm going to keep that over 1. And then we know that that's equal to the other fraction on the right side of the equal sign. And now I'm going to cross multiply. So I'm going to start by multiplying this x times every term here. Okay, every term, that x is going to get distributed through. So that's going to give me x cubed plus 6x squared plus 9x. Equals, and then on the other side, well, I'm multiplying by 1, so that's just going to stay the same. So x cubed plus x minus 2. All right, you should be able to see that if I bring this x cubed over, that's going to cancel out. I'm going to subtract the x over as well. And I'm going to squeeze in a plus 2 here to get that 2 over. Okay, so I'm trying to get everything to one side of the equal sign and set it equal to 0. So that's gone. So I've got 6x squared plus 8x plus 2 equals 0. All right, so I have a quadratic and I see I've got a GCF of 2. So I'm going to divide everything by 2, and that will give me 3x squared plus 4x plus 1. Now, remember, we're solving for x. So if we're solving, I want to either do the quadratic formula or factor this. But keep in mind that I have a lead coefficient that's not a 1, so I'm going to have to rainbow this. I'm going to look for something that multiplies to 3 and adds to 4. And remember, when we do rainbow, you bring down the first term and you bring down the last term. Okay, what multiplies to 3 and adds to 4? Well, that would be a 3. I'm going to put an x next to it, and 1. I'm going to put an x next to it. Okay, so these guys add to a positive 4x, and they multiply to a positive 3. Alrighty, so then we group, and we group. So I'm going to take out a 3x here, and I'm left with x plus 1 Here, there's nothing to take out besides a 1, so I'll take that out, and I'm left with an x plus 1. Okay, now I'm going to try to squeeze this in over here. So in my parentheses, I have 3x plus 1 and x plus 1 equals 0. And we're going to solve, so we're going to start the t-chart. I've got 3x plus 1 equals 0. So I'm going to subtract the 1. That will give me 3x equals negative 1. Divide the 3. And I have x equals negative 1/3. And then over here, we can just, take that little handy-dandy shortcut, and x will equal negative 1. But technically, what I'm really doing is setting that equal to 0 and subtracting over. Okay. Now, you just want to make sure, remember, we kind of want to do a quick check, and we want to make sure that none of these will make this fraction undefined, meaning we don't want a 0 here. Okay, but if I put in negative 1/3 here, I'm okay. And if I put in a negative 1 here, I'm okay. Okay, it doesn't make this denominator 0. All right, so those are our 2 answers for number 27. Okay, again, make sure you're taking notes. Okay, 28, let's do it again. So we are going to circle the base, run the race. And I've got x plus 1, that quantity raised to the 3rd power, equals 64. Okay. Now, I'd be a little careful with this one. We do want to get x by itself, and I know I have to get rid of the plus 1, but I can't really right now because it's stuck inside parentheses. And I have to get rid of this. The easiest way to get rid of this is do what we were doing on the last few problems. Let's just take this. You don't have to use brackets. You could use another set of parentheses, and let's just flip it. So if we take 3 and we take its reciprocal, what that's going to do is that's going to cancel these out because 3 times 1/3 is 1. We're going to do the same thing on the other side, obviously, and just make sure that you keep it as an exponent. Okay, so those guys are going to disappear. And so then on the left-hand side, we're going to get x plus 1. And then we have 64 to the 1/3 power. Now remember, power over root. So I am taking the cube root of 64, technically to the 1st power. I'm not going to write that. So I know that the cube root of 64 is 4. You can put that in your calculator. If you go to the math button, and then you look down, you'll see there's a cube root. All right, and then all we have to do is subtract 1 here. And so we have x equals 3. That one wasn't so bad, right? Okay, let's look at the last one. All right, so 29. Circle the base, run the race. 5x minus 1. We're going to raise that to the 1/3 power, equals 4. Let's do the same thing that we did on number 28. I'm going to get rid of that 1/3 power by multiplying by its reciprocal, which is 3 over 1, or just 3. Okay? That will cancel this out. And then I will be left with, on the left-hand side, just 5x minus 1. And on the right-hand side, I'm going to be left with 4 cubed, which is 64. We're just going to add 1. And I am going to divide by 5. And that will leave me with 13. There we go. There's your answers.